Hey, what's up? This is Madan Sir here, and I have come up with another very important and at the same time very interesting topic from aldehyde ketones and carboxylic acid. This is quite a popular one, and you definitely need it. You're definitely going to understand it quite an easy way, and you also going to take every moment of this particular lecture like it's something you needed and you desperately wanted something. What this is something I'm talking and I'm praising so much about. This is a very important chemical distinction topic from alcohol, aldehyde ketones and carboxylic. This is called tolerance test, right? So what this tolerance test is? Tolerance test is about it's about differentiating aldehyde from the ketones, right? So this is one of all those methods which helps you to chemically differentiate an aldehyde from ketone, right? So let me introduce to you, and then I will do the writing part there. Tolerance test involve a chemical which is called tolerance reagent. What this tolerance reagent is? This is scientifically called ammoniacal or ammonium silver nitrate, right? So ammoniacal silver nitrate is the scientific name of the chemical, also called tolerance reagent. So when you react an aldehyde, remember this tolerance reagent is a mild oxidizing agent. So it's not a powerful, it's not a strong oxidizing agent. So what happened here, when you react an aldehyde with the tolerance reagent, the aldehyde undergo oxidation and converts into a carboxylate ion, right, while the tolerance itself get reduced. So what reduction, what oxidation is coming, let's take you through the each and every part there, and this is really going to be very important. Maybe I need to make one more lecture based on this one, but let's see if I'll be able to complete it right here or not. So like I said, the topic we have is called tolerance test, right? Tolerance test. Now the question is, what is the objective of the test? So what I'm writing first one is the objective of the test. Objective, right? So objective is chemical distinction. You need to be very careful. This is a chemical distinction topic. Chemical distinction between aldehyde and ketones. So the first thing I'll let you know is what is the objective, what is the purpose of this tolerance test. So this is used in differentiating aldehyde from ketone by a certain reaction. What second thing is, what is a tolerance reagent, right? So tolerance reagent I'm making you go through. Tolerance reagent. This reagent is called ammoniacal silver nitrate. Ammoniacal silver nitrate, right? And this is always used in its fresh form, right? What does it mean? You prepare this reagent and you have to use it immediately, right? So I'm adding this point, freshly prepared, freshly made. I'm not adding prepared, I'm adding freshly made. Now let's find out how this reagent is prepared. So the third basic and very important thing I'm taking you through is its preparation, right? Its preparation. So a tolerance reagent is prepared by silver nitrate solution, AgNO3, right? I'm not writing the physical state because probably that's not something important. So AgNO3 is treated with ammonium hydroxide, NH4OH, right? And this result formation of your tolerance reagent, it's called NH3 whole twice with a positive charge here. So this is your basically tolerance reagent. This is your tolerance reagent. Tolerance reagent, oxidizing agent. So this is your oxidizing agent, right? And apart from that, another product you also have ammonium nitrate, but that's not something important. So this is your Tollens reagent. Now, what fourth very important thing about is, it is a mild oxidizing agent. Tollens reagent is mild oxidizing agent. You have to be very, very, careful learning this. Mild oxidizing. So this is a mild oxidizing agent. Now, why this is mild and what's the advantage here? Pay attention. It reacts with aldehyde and not with ketones. Why? Because this is mild one. If you remember that very previous lecture, I told you why oxidation of ketone is slightly different from the aldehyde. Because a ketone has steric hindrance. Which prevent it from undergoing reaction. So when it undergo oxidation, it require two very important conditions. One, strong oxidizing agent, and second, higher temperature. But we don't have this. This is a mild oxidizing agent, so this will not react with the aldehyde. What that means, that fifth point, is that when you react an aldehyde with Tollens reagent, which is your AgNH3 whole twice, it produces, this is something, I'm mainly focused over. This form, a carboxylate ion, RCOO negative, right? Apart from that, you have to be understand that it's also produce, silver. It produces silver. So what is happening here? Silver has an oxidation number of +1 here. In case you do know. If you do not, you have to, go back and check out from the coordination compound. But in case you do not, I would say learn it right here that silver is having a +1 oxidation state, but there silver is having oxidation state of 0. So what is happening here? This is undergoing reduction. This is your reduction part. And there you have your oxidation part. This is your oxidation part. So what that means, aldehyde is getting oxidized while the silver is getting reduced, and it produces silver, in solid form. There are more coming up, so don't, change your mind right here. Plus, this also produces water, and along with that, it produces ammonia also, right? So these are some of the byproducts. Now, what is very important here is that, how does this reaction takes place and what are the significance here? When an aldehyde reacts with this freshly prepared silver, ammoniacal silver nitrate, which is the Tollens reagent, it oxidizes the aldehyde into carboxylate anion, and the silver itself gets reduced, and it forms silver. So what happens? This silver produced is, it makes a mirror-like, surface inside the beaker or test tube or whatever you are taking for your experiment. So it forms a white silver-like, layer, in which you can see your image, which basically act as a mirror, right? So this is, this is converted as a, silver, which act as a silver mirror. Now there is something very important. That is also the reason, this test is also called silver mirror test. Let me repeat back because I was a bit hazy here. I was saying, since silver is getting reduced, so it comes in solid form, and inside the beaker where you are performing the experiment, it forms a layer, right? And on that layer, you can easily, see your image, or it's more like, a mirror, not exactly a mirror you see in your everyday life. So that's the reason this is also called silver mirror test. Right? So an aldehyde will react with, in this manner, but a ketone will not react, right? So I'm going to make one more writing part here. Let's talk about the sixth one here. Ketone, let's take any ketone here. A ketone, when react with Tollens reagent, there is no reaction here. The reason I told you, because aldehydes are polar, they are having less steric hindrance, so they undergo reaction even with a mild oxidizing agent. But because ketone has a strong steric effect, so it requires strong oxidizing agent, right? And but the Tollens one is a mild one, so it cannot oxidize the ketone, and therefore ketone does not respond to this. So what you just learned here, that aldehyde react positively with the Tollens reagent, but ketones do not. So this is how you can differentiate. So when it comes to write equation for your paper in your board exam, that's what you have to do. These are the two very important equations you need to mention in your exam. Remaining, it's something I told you everything else about the Tollens test, right? So let me repeat back one last line here. The Tollens test comes out to be positive with aldehyde, but it comes out to be negative with the ketones, right? So that was our very important topic here, and I tried almost everything, making you go through your head. And this will the only concern was to make you learn everything and understand in a very simple way. But another very important thing, which I will do in the next lecture, is there anyone other compound that also react with Tollens reagent, or is it the only aldehyde, right? The question is, if it's the only aldehyde which respond to Tollens reagent positively, or is there are there some other? So there are some, I must hint you right now, I will do it next time, but there are some compound which also respond to the Tollens reagent in a positive way, right? So this is where I need to complete this. In case you have you need to take a look here, just take a look and let me know if there anything you have to okay, so I have to wind this right here. I'll say thanks for watching, and stay tuned, because tomorrow I'll be taking the Tollens reagent part 2, and I will let you know what other chemical compounds can react with Tollens reagent and respond positively, right? That's it.